In this lecture, we will cover our first circuit theorem, which is the source transformation. Circuit theorems are used to reduce the complexity of an electrical circuit and make the circuit analysis simpler. In the source transformation, we replace a voltage source and series resistor by a current source and parallel resistor, or we do the opposite operation. In the superposition theorem, the response of a linear circuit to several inputs is equal to the sum of the responses to each of the inputs working separately. So we can simplify the circuit analysis by creating equivalent circuits and adding the responses of these sub-circuits to find the final response. In Thevenin theorem, we replace a circuit by a voltage source and a series resistor. Similarly, in the dual of the Thevenin theorem, Norton theorem, we replace a part of a circuit by a current source and a parallel resistor. And in our final theorem, the maximum power transfer, it describes the condition under which one circuit transfers the most amount of power to another circuit. For source transformations, we assume that we have a voltage source in series with a resistor, which is connected to a circuit B. Or similarly, we assume that we have a current source with a parallel resistor, which is connected to another circuit B as well. Our objective is to convert this voltage source with the series resistor to the equivalent current source with the parallel resistor. This might make circuit analysis simpler. Replacing the non-ideal voltage source by the equivalent non-ideal current source does not change the voltage or current of any element in circuit B. This is the condition for source transformation. So now we need to find the condition in which this transformation can happen. So source transformation theorem. A voltage source Vs with a series resistor Rs and a current source Is with a parallel resistor Rp are equivalent if the following conditions are met. Rp is equal to Rs and Vs is equal to Rs times Is. In order to show this, let's write the KVL equation for circuit 1 and KCL equation for circuit 2. So let's write KVL for circuit 1. What will this be? Rs times I plus V will be equal to simply Vs. Let's write KCL for circuit 2. Here I have V. I have a current going out this way, current going out this way, and Is is entering. So I plus V over Rp will be equal to Is. Let's multiply everything with Rp. Rp times I plus V is equal to Rp times Is. Now, I want these circuits to be equivalent, so then these two equations should be equal to each other. This would be the case if Rp and Rs are equal to each other, as pointed out here. And secondly, this will be the case if Vs is equal to Rp times Is, as pointed out here. So, therefore, these two conditions are the conditions for the source transformation. Alright, we need to find the source transformations of the circuits. Here, Is will be equal to 28 volts divided by 14 ohms and 2 amperes. And Rp will be equal to 14 ohms. In this case, Rs will be obviously 12 ohms. And Vs is a little bit more complicated. We need to look at the signs. Polarity. Here is plus, here is minus. I is pointing downwards. Therefore, it will be 24 volts. We could have also done this source transformation in this form. Here I have Rs. Here I have the source with these polarities, and I write minus 24 volts as the value of the voltage source. Here are the source transformations. Now we will learn how to use these transformations in order to solve the circuit analysis in an easier way. So we need to find the current I by reducing the circuit using source transformations. So I can do a source transformation in this part of this circuit. This is easy. So I will draw my circuit plus minus 5 volts, 5 ohms, here the 20 ohms, and now comes the source transformation. So the 30 ohms will be parallel resistance, and I will have this current source which will have the value of 3 volts divided by 30 ohms with the up sign 0.1 amperes. Now as you can see, I can reduce the circuit by taking these two parallel resistances and finding the equivalent resistance. 20 ohms in parallel with 30 ohms will be equal to 1 over 1 over 20 plus 1 over 30, which is equal to 600 divided by 50 and 12 ohms. So I reduced my circuit. What will I do next? Let's draw the equivalent circuit and see what we can do. Here I have 5 volts, 5 ohms, this 12 ohm resistor, and here I have 0.1 amperes. So I will again create a source transformation for this part of the circuit. And that will become plus minus 5 volts, this 5 ohms, now this series 12 ohms, and since it is just pointing upward, I will have plus minus 1.2 volts. So this is my new source transformed circuit. The current I is still the same current I, and it's flowing over this 5 ohm resistor. Using source transformations, we generated the circuit on the right from the circuit on the left. So simply I will write the KVL for this circuit, which will be 5 times I plus 12 times I plus 1.2 is equal to 5. So accordingly, 17 times I will be equal to 3.8, and we will have I is equal to 3.8 over 17 amperes as the current value. Now I need to solve this question using source transformations. It's always confusing for me if the current source is in the middle of the circuit, so I will simply do a trivial operation here and then put my current source to here, 3 amperes. We have 4 ohms. Then here I have 2 ohms. Here I have my 8 ohm resistor. And let me do my first source transformation. I will put this 3 ohms here. And I will put here a 4 ampere current source pointing upward because the plus sign is towards the 3 ohms. Now, what else can I do? I can source transform this part of the circuit now. So accordingly, it will become minus plus 12 volts, 4 ohms in series with 2 ohms. So I will simply write here 6 ohms. Here I will put 8 ohms. Here I will have 3 ohms. And here I will have 4 amperes pointing upward. I can source transform once again this part of the circuit. Accordingly, I will now write this here. I will have 2 amperes pointing downward because positive is towards the bottom side of the circuit. I will have 2 amperes 6 ohms, 8 ohms, over which I need to find the voltage V0. Here 3 ohms and my 4 ampere source. Now what do we have here? 6 ohms is in parallel with 3 ohms. So the equivalent value for those will be equal to 2 ohms. And 2 ampere current source is in parallel with 4 ampere current source. But one of them is pointing upward, one of them is pointing downwards. The resultant current is 2 amperes pointing upward. And I have my 8 ohm resistor over which I will calculate my V0 as well. Let's solve the remaining part of this question using the node voltage analysis. Here I define my node as V0. V0 over 2 plus V0 over 8 is simply equal to 2. From here I have 5V0 is equal to 16 and I find V0 is equal to 3.2 volts. So I solved this circuit using multiple source transformations, which allowed me to reduce the resistor values to equivalent resistances, and I found this way the solution of this circuit rather quickly.